Alright, testing 1, 2. Hopefully I can be super quiet with this. Okay, so we're going to look at methane here, and we're going to look at the orbitals. So what you want to do first is just look that this has 4 bonds, and we're going to say that this is sp3 hybridized, okay? And we're going to look at the carbons here, and we're going to say that these are sp2 hybridized. Okay, in other words, and I like writing these, S1, P3 hybridized. Okay. S1, P2 hybridized. Now, in the case of this one, if we look at the electron configuration of carbon by itself, electron configuration of carbon by itself is 1s2, 2s2, 2p2. Okay, it has 6 total electrons. It has 4 valence electrons. If we look at the energy diagram, right, 1s, 2s, 2p, remember, 2px, 2py, 2pz. All right, for filling electrons, 1, 2, 3, 4, 5, 6. Now we just need valence. And our valence electrons are here, and they're here. But carbon needs to make 4 bonds, right? It needs to make 4 bonds. So what we need to do is bring one of the electrons from the 2s, and we want to promote it, and we want to put it to a higher energy level here. Here. Okay. So we'll take one away from there. But what is going to happen? What is going to happen is that we're going to create a 2p and sp3 hybridized orbital. But what will happen is that it's going to sit I think there's 4 of them. There's 4 of them. These are all S1, P3. And these will all have 1 electron in them, one of the 4 valence. Okay, and it is going to be in between the levels here. So it's going to be, this is energy. But as energy goes up, stability goes down. So it's going to be more stable. And what an sp3 orbital looks like is that when an s and a p overlap, when this s comes here, the result is something like this. Okay, this is an sp3. So from this carbon in methane, it's going to have these sp3 orbitals coming off of it. And that is what it's going to create. its ability to create 4, and these are its 4 valence electrons, which are going to be most likely found, I believe, in these areas here. Okay. The s orbital adds to one lobe of the p, subtracts from the other lobe of the p to form the hybrid sp3. So these are all s1, p3, and they have 25% S characteristic, 75% P characteristic. Okay. And what happens in methane is that you have your hydrogen, which just has an S, and your S, and your P overlap. And these are all sigma bonds. Sigma bonds. And what happens here is with an sp2 is that your carbon has the same thing. But what happens is that there is a p orbital that is unhybridized. Because remember, p orbital that is unhybridized. And when the 2 carbons come together, that's where that pi bond comes into play. And that forms 1 pi bond.